we talked about the IDS standard, and in my next presentation, which is named Bridging Information Gaps in the AECO Industry, a prototype framework for standardized product data provision. So again, let's talk about the importance of product data in the AECO sector. And of course, we need reliable and accurate data because they are basically crucial for the whole sector, encompassing architecture, engineering, construction, and operations. And this data is essential for design specifications and material properties. And of course, like always, the goal is to ensure precision and timeliness in all operations. Of course, we need efficiency gains using digital models. So the increasing use of digital models in the AECO sector enhances efficiency and accuracy in planning and implementations. And of course, these kinds of models help streamline processes and reduce errors and improve overall project outcomes. And there's also the sustainability and EU Green Deal, which basically emphasizes the importance of sustainable construction practices. And this initiative citizens the need for detailed and accurate product data to support green building efforts. So again, we are facing different challenges with product data in the AECO sector. So a very huge issue is the fragmentation and lack of standardization, because product data is basically primarily represented in PDF documents, which we see on the right side. This was provided by dormakaba, where we work with them in this kind of project. And the extraction of data from these PDFs heavily relies on manual processes. And this leads, of course, again, to a fragmentation and a lack of standardization across the industry. And of course, we already face centralized platform and integration issues like Cadenas or BIM object, but they provide in general a first repository for product data. But despite this, there are significant challenges in data integration, maintaining the consistency over these different kinds of challenges. And these issues impede seamless data flow and efficiency across platforms. So the benefits and challenges of product data templates. At first, I want to talk again, of course, about the standardization and simplification, because BDTs basically standardize product attributes and simplify data updates. We also have two DIN norms regarding that. It's the DIN and ISO 23386 and 23387. And another huge advantage is the machine readability. So BDTs are designed to be machine readable from ground up, and this facilitates easy data exchange between systems, and it ensures data consistency in maintenance and accuracy. Of course, as good as it sounds, there are different challenges applied to be. So we have, for example, the complexity, integration issues, and need for consistent data again. So let's talk about the problem statement itself. So on the left side, we have the planners. And the planners, they face basically when they're working, inefficiencies and risks arise due to inaccurate data that they receive. And there are challenges evident during planning, design, tendering, procurement, construction, and maintenance. And we have significant delays in inaccuracies, which basically occur in the project execution. And on the other side, we have the product manufacturers, which basically ensure up-to-date and consistent product data across platform, which is really challenging because there are a lot of platforms. And of course, again, a lack of standardization, which leads to inefficiencies and higher data management costs. And data duplication across systems increase risk of inefficiencies, inconsistencies, and errors. And we are integrating new product into integrating new product into existing data ecosystem, which is really complicated. So what are the requirements for efficient product data exchange? At first, of course, we need standardized data formats which ensure seamless integration into various software platforms and tools. We have interoperability and real-time data access that are crucial. And platforms should feature user-friendly interfaces and efficient data retrieval. And this slide you've already seen in the presentation before. This is just, we want to use the IDS standard again for this kind of application. So another screenshot, but a different use case this time. So we can see we have an entity IFC door that is external, and we're again asking the questions of which components require which information. So we have the property set pset door common, and there are different properties assigned to it. So for example, we have acoustic rating and again the fitting URI. So when we look about the proposal, we will find that the information orderer, for example, constructors, planners, engineers, have different kinds of use cases all over the industry. So we have, for example, planning and design, tendering, construction, maintenance, and even more use cases. On the other side, we have the information supplier. And with this proposed methodology, we can basically use this kind of information, and we have the information orderer that basically creates a request, and the information orderer basically specifies the information delivery specification, and stored to the IDS there are requirements and the applicability, and the information supplier receives this kind of IDS file. The good thing is that these requirements can be used and accessed for example, BIM cloud services like the bsDD or BIM portal. And we have in mind different mapping mechanisms in the future, because the information supplier basically has a lot of product data, and they can be, for example, used with a direct mapping, reference-based mapping, or AI-supported mapping in the future to be mapped to information within the bsDD or other cloud services. So the information supplier, after it receives the information delivery specification, basically starts the provision and returns the IDS with the requirements and applicability to the information orderer. And this is basically the whole process that we want to use for that. So the good thing about this is that we also have an integration with BCF API. So the BCF API standards for seamless data exchange, and the BCF API standard facilitates seamless data exchange in the AECO industry in general, and it enables efficient communication and coordination among project stakeholders. And the BCF API and BIM snippet objects help in requesting and providing data, and these tools streamline the process of data exchange and ensure accurate information transfer. And we can also see that on the right side, we have the request and provision. So again, we have the product data request.ids, and as a provision that is like returned from the provider is the product data IDS. So in conclusion, the IDS together with the bsDD can help to standardize data exchange for product manufacturers in the AECO industry, and improving data accuracy and efficiency, and it promotes collaboration and efficiency among AECO stakeholders while supporting sustainability goals. And of course, to prove this kind of concept, we introduced a successful test case with the door manufacturer, which demonstrates the practical applicability of the format for data exchange. And we have, of course, again, some limitations on the other side. So the IDS currently supports only alphanumeric data and not geometric data, which is highly limiting its scope. And the framework mainly supports model-based workflows requiring adaptation for non-digitized assets. And we have an integration with existing industry tools and system that poses challenges and requires further testing and validation across different use cases. And the future directions, I already talked about that in the graphics I've shown beforehand. So we need to analyze industry adoption barriers and facilitators and explore integration with existing data management tools. And we have to develop and test a broader prototype for various data queries and adapt framework for non-model-based workflows, and extend the IDS to include geometric data exchanges. So this could be some future directions. So thank you very much for your attention.